Alright, I want to look at the matrix that we had. I'm just going to call it Q, where it was composed of block matrices of A, 0, and B. And we were looking for an inverse that was going to be in the form of A inverse, 0, A inverse, and C. And we wanted to figure out what C was. Now I initially did this as making this a determinant argument that we could have done A times A minus B times 0 would be the determinant of Q. And then so the inverse of Q is 1 over the determinant, which in this case is going to be A squared times invert the AA and change the signs to this. And so we got this matrix. And in that case, that's going to become A negative 1, A inverse, A 0, negative B 0. And all said and done, we were able to get that Q inverse becomes A inverse 0, negative A inverse B, and A inverse. And I said I wasn't happy with how the book did negative A inverse B, A inverse. And I wanted to kind of look at this a little closely. And right after class, Xandar asked me about it. And what I did was we looked at it from a different viewpoint. We're saying if Q times Q inverse should equal the identity. And if we do that, that's going to give us, if we do the block matrix multiplication on it, it's going to give for the first element A times A inverse and plus B times 0, the 0 matrix. For the second element, C times 0. C times 0, not B times 0, right? Because I'm doing this times this. So A times A inverse 0 times C. And then for the second element, it's going to be A times 0 plus 0 times A inverse. For the second row, first element, it's going to be B times A inverse plus 0 times C. And for this one, it's going to be A times C. I'm not getting color. There we go, A times C. Right, because so for the second row, I'm going to get B times A inverse and A times C. And then for the last element, I'm going to get B times 0 plus A times A inverse. And that equals 1, and that equals 1. But this condition down here, this bottom cell condition, BA inverse plus AC has to equal 0. Let's see if I can get my back on the screen here. I've lost my pointer. Let's zip up. There we go. So this condition here comes about by that submatrix in the lower left-hand corner. So BA inverse equals negative AC, and we wanted to solve for C. C was the thing that we were having a problem with. Maybe if I do a rearrangement here, if we're solving for C, we'll say AC equals negative BA inverse. So to get C on its own, I'm going to left multiply by A inverse. And if I left multiply on this side, I'll have to left multiply on this side. And I get in the form that the book had, C equals negative A inverse B, A negative inverse. And I think this is probably the better way of proving that element coming across, is by using the condition that that bottom element has to equal 0. And so that bottom element having to equal 0 sets the conditions on C.